Hey everybody, hope you had a great day yesterday and hope everything's going well today. Today we're going to keep working with dilations. We're going to incorporate them into the other transformations that we learned in this unit. So if you have any questions on dilations from yesterday, please make sure you either write them down on that Google Doc that's attached to the classwork, or you can always reach out for a Google Meet. We'll have an open Google Meet today at 2 o'clock, so if you want to come join us then and ask any questions, it'll be from 2 to 2:30. So just pop on, and if you're not doing well on the BIM and you want to just pop on and ask questions, we can put it on the screen and just do it together. So you don't have to submit these things during this time. If you want to wait till later, that'd be fine as well. So here we go. They give us the vertices of a trapezoid. They tell us to dilate the trapezoid with respect to the origin using a scale factor of 2. So I didn't include a graph on this one because I want you to see that you can solve this without graphing it at all. So it says to dilate the trapezoid with respect to the origin using a scale factor of 2. Well, this is important. The scale factor is 2. So what does that mean? It means that we're going to multiply every single one of these ordered pairs by 2. So A prime, we're going to multiply everything by 2, so negative 2 is going to become negative 4. And negative 1 is going to become negative 2. For B prime, negative 1 is going to become negative 2. And 1 will be 2. And C prime will be 0, 2. Last one, D prime, would be 0, negative 2. Alright, so that is how we dilate it with a scale factor of 2. We don't have to graph anything, we just multiply every single one of the ordered pairs by 2. Now I have to translate it 6 units right and 2 units up. Alright, so 6 units right. If I'm going 6 units right, that means I'm adding 6 to the x value. 2 units up, I'm adding 2 to the y value. So I have to add 6 to this, negative 4, and I have to add 2 to this negative 2. So negative 4 plus 6 is 2, and negative 2 plus 2 is 0. So A double prime is 2, 0. B double prime, we'll add 6 to the x, add 2 to the y, and we get 4, 4. C double prime, get 6, 4, and D double prime, get 6, 0. Alright, so those are all of our points. That's A double prime, B double prime, C double prime, and D double prime. So we didn't have to use a graph at all. We just found the coordinates of the image. So we did that by multiplying all the originals by 2, and then we added 6 to the x value, and we added 2 to the y value because we were going 6 units right and 2 units up. If we were going to the left, we would have subtracted from x, and if we were going down, we would have subtracted from y. But since we're going to the right, we added to x, and up, we added to y. Alright, for this problem here, we're going to graph the triangle, TRS, because it says to draw the triangle and its image after a dilation with a scale factor of 3, then a rotation 180 degrees about the origin. What are the coordinates of the triangle? T double prime, R double prime, S double prime. Alright, so I'm going to go ahead and graph this triangle, and if you have this printed, you can do the same. I'll probably just pause it so you guys don't have to painfully watch me draw the triangle. Alright, so I've graphed T, R, and S, and then the first thing I have to do is draw a triangle, its image, after a dilation with a scale factor of 3. So that means that every single thing got multiplied by 3. So T, I'm going to multiply those ordered pairs by 3, and I'd get negative 6, 9. That would be T prime. R prime, if I multiplied 3, 2 by 3, I would get 9, 6. And s prime, if I multiplied 3, 1 by 3, I would get 9, 3. Alright. It then says a rotation 180 degrees about the origin. So let's think about what rotation was. So rotation 180 degrees. Do you remember what happens to the x and y coordinates? Well, if you said they both become opposite, you'd be right. So it's the opposite of x and the opposite of y. So we have 6, negative 9. R double prime. Be negative 9, negative 6. And s double prime become negative 9, negative 3. Alright, so I'm going to go ahead and graph the image here. I'll pause it so that you guys don't have to, again, painfully watch me graph it. Alright, so here we go. Here is our shape. So it's been dilated by scale factor 3, and it was rotated 180 degrees about the origin. Okay. And then the last thing that we're going to do today is they're going to give us two figures, and they're going to say, describe a sequence of transformations in which the blue figure is the image of the red figure. So sometimes these have multiple answers. Sometimes, you could say a bunch of things and keep going, but usually the correct answer will be found in 2 or 3 steps, sometimes 1. About 1, 2, or 3 steps, usually you can get the blue figure to the red figure. So just describe a sequence of transformation in which the blue figure is the image. So remember, that means that the blue figure is the second figure. So the red figure is the original. So we're going from red to blue because it says in which the blue figure is the image of the red figure. The image is after the transformations. The pre-image is the original one. So we have to look, how can we get from the red to the blue? Well, did it get bigger or smaller? Even though I can't hear you, I know you said smaller. So how much smaller did it get? What did we multiply the side lengths by from the red one to get to the blue one? So the red, this side length is 2. It looks like it corresponds with this side length, which is now 1. And the bottom used to be 4, and now it's 2. So how would I go from 2 to 1 and 4 to 2? What would I have to multiply 2 by to get to 1? And what would I have to multiply 4 by to get to 2? Well, if you said a half, I would agree with you. So I would say the first thing would be a dilation with a scale factor of 1/2. Alright, and then the next thing that happened is it looks like it got flipped over. Right? I would say that it probably just got flipped. From this side, the left-hand side, it's on the left-hand side. It's just that this was on the bottom, now it's on the top. So I have to flip it over on the x-axis. So I think the first thing I would have done actually, well, it wouldn't matter. So after you do that, if the scale factor of 1/2, you would reflect it over the x-axis. Well, let's look what our points would be now. Alright, so let's look at just one of these points. We have 4, negative 2. That is this point right here. Alright, we'll do 2 points just to make sure. And we also have 4, negative 4. Alright, so this point looks like it becomes this point. So I want to see, how does it become 2, 1? And then this point here looks like it becomes 2, 2. Alright, so if we do a dilation with a scale factor of 1/2, that would make this into 2, negative 1. And the reflection over the x-axis would make the y value opposite, which make it 2, 1. Okay, that works. And for this one, this would become 2, -2. And the reflection of the x-axis would make it 2, 2. So this is it. This is my answer, and I'm all done. If you want, you can always go and do this first. Say how would I get from this to this as far as the numbers. But just check to see if it's the same size. If it's not, it's a dilation. You might have to some people might have said, oh, well, we have to move it left or right. But notice when we do the dilation with a scale factor of 1/2, when we do that dilation, we're bringing it closer to the origin. That's why it's about the origin. So when you're multiplying all this by 1/2, that's why it's bringing it closer back to the origin. So that's why I moved it over here. So before you think you have to move it left or right, if you have to do a dilation, do that first, and then see where you have to move the figure. Alright guys, but that's it for today. So, there's a couple problems on big ideas. If you have any questions, please write them down on the doc, or please feel free to join us this afternoon at 2 o'clock for the open meet. Alright, have a good rest of your day.